Hello, bacho. Hi, hello everyone. This is your Vignesh from your Mr. Vignesh Tutorials channel, and here comes your next session. This section is all about for your, I can say, M1 Mathematics Engineering, of course. I have been uploading a few more videos for M1 Max Engineering in these last few days. So in this session we are going to start with the same chapter matrices only. In that next upcoming topics we are going to see. So let's cover them. So without any delay, let's start our session. Okay. So okay students, let's start our session. Today date is 10th September. It is our M1 Maths Engineering. I think it's our class 5 or lecture 5, whatever it is. We are dealing with the unit matrices. In that today our topic is Cayley-Hamilton theorem. Cayley-Hamilton theorem or Cayley-Hamilton method, whatever it is. Okay. Let's see here. Quickly observe that. In our last section we have seen what is rank of a matrix and normal form characteristic equations, right? Here in our Cayley-Hamilton theorem we are going to find the A and its characteristic equation. What is A? A is our matrix. Let's take an example. 2 minus 1 1 minus 1 2 minus 1 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 1 minus 1 2. Let this be our 3 into 3 square matrix. Okay. We are taking an example. Let's solve for it. We know A minus lambda I for every non-singular vectors there exists A which has characteristic equation, right? That is this one. If we see this matrix, it will be 2 minus lambda minus 1 1 minus 1 2 minus lambda again minus 1 1 minus 1 again 2 minus lambda. If we do det for this, it should be is equal to 0. Okay, that's our point. Now upon solving this, you will be getting, upon doing some operations and solving, you will be getting lambda cube and okay, upon solving this, you will be getting lambda cube minus 6 lambda square minus 9 lambda minus 4 is equal to 0. You will get plus 9 lambda minus 4 is equal to 0. So this is the equation you are going to obtain. So every lambda is equivalent to your matrix A, and matrix A satisfies this characteristic equation. That's what your Cayley-Hamilton theorem is going to say. So we'll substitute here A cube minus 6A square plus 9A minus 4. Nothing is matrix means you have to keep I. Okay, I is a unit matrix here. Here thing is our matrix also satisfies the characteristic equation. That is what Cayley-Hamilton theorem says. Okay, now let's observe here. My A cube minus 6A square plus 9A is equal to 4 into I can write. Yes? Yes or not? So if I multiply with A inverse, I will multiply with A inverse on both sides. So it becomes A square minus 6A plus 9I is equal to 4A inverse. So if you find this value by substituting the value of matrix A, you will definitely get the value of A inverse. So this is what you mean by Cayley-Hamilton theorem. Without going for adjoint A, det A and all, you can directly find the A inverse value with help of this Hamilton theorem by characteristic equation. So this is what it means. Simply you can multiply A into A, you will get A square. A you will substitute as it is. Identity matrix you know. You will substitute in this. It's very simple. You will be getting it in 2 minutes. Whereas if you go for normal A inverse method that I will tell you in next class, that will be a little tricky and it will go like up to 5 minutes. Okay. Please take a note out of it and take a screenshot of it. Please take a screenshot of it. And here the order is n equal to 3 actually. In general, if the order is n, our lambda is going to have solutions like lambda power n. The equation would be like lambda power n plus a1 lambda power n minus 1 plus a2 lambda power n minus 2 plus so on plus an last is equal to 0. This would be an equation and every a satisfies this. A power n plus small a1 a power n minus 1 plus small a2 a power n minus 2 plus so on plus an is equal to 0. It will satisfy this equation. This is what it means. So we have to remember this one and your characteristic equation and this statement satisfies. And here you are going to find your A inverse is equal to 1 by 4 of A square minus 6a plus 9i. This value you are going to get. So we'll solve for this and we'll find the A inverse value. Okay, take a screenshot of it. Okay, now let's see we are getting it or not. Let's see, let's get into this one. 1/4 of a square. I want my a square. What should be my a square? 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 into 2 minus 1 1 1 minus 1 2 minus 1 1 minus 1 2 minus 6 times of 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 plus 9 times of I means 9 9 9. Rest of all are zeros. Okay, I hope you understood this. So that would be equal to 1 by 4th of, if I multiply this one, 4 plus 1 5 plus 1 6 and minus 2 minus 4 minus 2 minus 4 minus 5, then 2 plus 1 3 plus 2 5. So here minus 2 and minus 4 and minus 5 we'll be getting the same values, like we'll be getting these values. I hope the value would be like this. Minus 6 times of that one is 12 minus 6 6 minus 6 12, sorry, this is plus 6, 12 minus 6 6 and 6, this should be our minus 6 and 12 and it's 6, it's minus 6, sorry. Okay, then again 6 into 1 is 6 minus 6 and 12. Okay, I hope it's clear. Let's see this once again. 2 into minus 1 is minus 2 minus 4 minus 1 minus 5. Okay, minus plus 1 plus 4 5 this one 6, this should be 6, sorry, this should be our 6 and -1, -3, -5. This should be our -5. A small mistake, students. -5. And 2 plus 1, 3 plus 2, 5. It's correct. -1, -3, -5. This should be -5. And 1 plus 1, 2. This should be +5. So this is correct exactly. So this should be our matrix. Now this is our 6a plus 9 is. Now I will add all those. It would be it will be like, if I add 6 plus 12 is 18. Sorry, 6 plus 9 is 15 minus 12 is 3. Then -5 minus 6, sorry, -5, 0 is -5. -5 plus 6 is 1. 5 minus 6 is -1. And -5 plus 6 is 1. 6 plus 9 is 15, minus 12 is 3. -5 plus 6 is 1. Yes. 5 minus 6 is -1. -5 plus 6 is 1. 5 plus 9 is 14. 14 minus 12 is 2. There is something mistake on. No. 5 plus 9 is 14. Is correct. Minus 12 is 2. This is what you get in the matrix. I hope it should be 3 only, right? You should get 3 or what? No, when you are adding 6 plus 9, it is 15 minus 12 is 3. Okay, but 5 plus 9 is 14 minus 12 is 2. Okay, it's correct. Now if I do this operation, I will be ending up with 3 by 4, 1 by 4 minus 1 by 4, 1, 3 by 4, 1 by 4 minus 1 by 4, 1 by 4, 2 by 4. So I'll be getting this matrix. Now this is our A inverse. Our A inverse is simply this matrix, you can say. It will definitely be valid if you do with your normal inverse method that I will tell in the next class. So I hope you all followed till here. Please take a clear note of it and don't make mistakes. If you make also, correct it there and then itself only. Any kind of doubts, please mention in the comment section. I'll be helping you out. Take a screenshot of it. So I hope you enjoyed this session. It's just about Cayley-Hamilton theorem, only straight away one concept, and don't get confused. So this is what about this session. I hope you would like it. Please like, comment, share and subscribe my channel and press bell icon for further more updates. Until then, stay tuned. Signing off, Vignesh.